join and we can start our class. I know I have promised you a game, so I'm thinking of that game on Monday. So I'll take Asra ma'am's class on Monday and we'll play a game. Okay?
Ma'am, you said today only, no, ma'am.
Yeah, but our chapter was not over, right?
Okay, ma'am.
So if it is over only, we will get so many questions to play. So,
Okay, ma'am.
so before the class on Monday, complete or watch all the videos of this lesson. Okay, you have tomorrow free, right? So that you will answer the answer very quickly and fastly and correctly when we play the game. So that you will come like first, second, third positions. Okay.
Okay, ma'am.
Okay. Is there anyone new who haven't played that game?
No, ma'am.
So then it's okay.
No, ma'am.
So we won't be losing time there also. So we'll play it very fast then. If you want, I'll just put a simple logic one kind of thing in the group. It's a max one. It's like, but it's very fun thing. So maybe you will like it for a practice. So I'll put that after the class.
Okay, ma'am.
Yeah, we'll wait some 2 more minutes and come up and start our class. So is there anyone new who haven't attended last class? So who missed this last class? Is there anyone new? Okay, so then we can start. So what were the things we were discussing in the last class?
Types of friction. Types of friction.
Okay, types of friction. In that,
Static friction. Sliding friction. Rolling friction.
okay, now I will ask what is that to like calling names. Okay, so whom should I ask? Okay, Madhuri. Okay, I'll ask Madhuri one question. So be ready. So the first question is, what is sliding friction? So I'd like to have Rajarajeshri to answer this question. So what is sliding friction?
The force required to overcome friction. It starts with moving from rest.
I asked sliding friction.
Okay.
So tell me, what is sliding friction?
The friction which moves in motion.
when we slide one object or another, the friction which happens there, right, which happens between those two surfaces in contact, that friction is sliding friction. So yeah, the next question is, can you define rolling friction? What is rolling friction? Or definition is nothing needed. You just tell me what is rolling friction, what you have understood. So I'll ask Mahidar.
Ma'am, I'm saying. Ma'am, rolling friction sometimes called rolling friction, ma'am, or rolling drag. Is the force resisting the motion when a body rolls on a surface, ma'am.
Okay, now Mahidar just said a word drag. So what is drag? Do you know what is drag?
Yes, ma'am.
What is drag?
Ma'am, if we keep on the land, if we drag this one, it will move, ma'am.
Okay, so the drag you meant is sliding kind. Is that what you are seeing? So the drag you meant is like dragging something like that. The word is like sliding. That meaning you are using. Is that correct?
Yes, ma'am. It will roll. When we keep it ball, it will. If we drag, it will become in roll, ma'am.
Okay, I'm getting your point. So rolling friction, we can say that when you are trying to roll, when two objects are rolling over, or when one object is rolling over another, then the friction that occurs between those two objects are called rolling friction. Okay. Now, yeah, okay. The next question is, which is greater, static friction or sliding friction? I would like to have who was that? Yeah, one new name I saw somewhere. Okay, I would like to have Mokshida to answer this. Okay, Mokshida.
Static friction is greater, ma'am.
Okay, who was answering? It was not Mokshida, right? Okay, the question.
Ma'am, can you hear me?
Okay. Wait. So I am going to ask this question. I am going to ask this question to Mokshida. So I didn't hear Mokshida's answer. I heard someone else's answer. So I want Mokshida to answer this one.
Okay. Static friction is greater, ma'am, because static friction. Static friction.
In static friction, the friction will be greater, ma'am.
Okay, Sirishna, let Mokshida try to answer. Okay, I'll give you a chance. And I'm seeing answers in chat box also.
Static friction means at rest, ma'am. Then when at rest, we can't move, ma'am. Move any object, ma'am. We can't move any object.
Okay, so I'm getting
because more friction is acting there.
Okay, Mokshida, we'll come to that. Okay, then I'm saying something like I saw some answers here. Sliding friction is greater. So Rajeshwari, can you tell me how sliding friction is greater than static friction? Rajeshwari? Okay, then sliding friction is not greater. Yeah, I think it was a mistake. So now we have a question here. So I would like Pranati to read this question. Okay, Pranati?
Static friction comes into play when we try to move an object at rest.
Okay, you skipped one sentence. State true or false was the question, right? So state true or false.
True or false.
Okay. So answer through chat box fastly. I need to get all 13 answers now. Okay, Venkat has answered. Pranati, Ramya, okay, Sushmita, that's. Okay, Srilata is your name, Srilata?
Yogesh, ma'am.
Yogesh, okay. Yeah, so everyone answered? Okay, then let's check if this is true or false. It is true. Yeah, everyone got the correct answer. Okay, then let's move to the next question. Okay, I would like to have Madhuri to read this question. Madhuri, can you read?
Ma'am, I will read, ma'am.
Who is that? Okay, Shweta. Okay, read.
Ma'am,
Okay, Shweta, I didn't
Sliding
hear.
friction greater than the static friction.
Okay, what is your name, dear? It is not Yashwida, right?
Mahidhar, ma'am, Mahidhar.
Okay, Mahidhar is in Yashwita, that ID. Okay. Okay, Mahidhar, thank you. So, I hope everyone has answered that. I'm getting so many. Okay, Madhuri, it's okay. Okay, Sirishma. Oh, sorry. Okay. Yeah. So, what about? Okay, I only got some answers. I didn't get answered from Venkat, I think. Yeah, Venkat. Okay, Venkat, I got.
Ma'am, I answered.
Yeah, I got. Kusuma, I didn't see your answer. Where is Kusuma's answer? Okay, answer first. We are going to see the answer now. Sliding friction is greater than the static friction. So, yeah. So, almost, all of you have answered it is false. Okay, then let's see. Sliding friction, is it greater than static friction or is it less than static friction? We just discussed also. So, okay. So, it is false. Your answers are correct. Okay, children, now from next class onwards, please try to join a little early. Like I am waiting till 10, like for you for at least 10 minutes, but still you are not joining on time. So, please join first because you will be missing out something. Okay, and the next question. Okay, Krishna Kumar, read this question.
State true or false. Sliding friction is greater than the rolling friction.
Now, all of you answer through the chat box. Okay, all have answered. Yeah, almost everyone has answered. Is there anyone whom has to finish now? Okay, Kusuma. Then Yogesh, I didn't see. Yogesh.
Ma'am, I kept,
Yeah.
ma'am.
Okay, got it. Okay, then let's see. All have answered it to be true, so let's see if it is true. Yeah. So, all the three questions, all of you have answered. That means all of you have understood the concepts, I think so. So, let's move on to something new today. So, we have seen, types of friction, that is static, sliding and rolling. Now, I have given you one assignment, home assignment, right? Okay. I have told you, but I couldn't give you like in a slide, I think so. So, let's see this question. So, in all the cases we have seen friction acts between two solids, right? So,
Yes, ma'am.
so what about liquids and gases? So,
Yes, ma'am, it will act.
it will act. Who is saying? Okay, Sirishma is saying it will act. Okay. Now,
Yes, ma'am.
my question is, does liquids and gases exert friction on objects moving through them? Okay, I got Rajarajeshwari's answer is, answer first. Does liquids and gases exert friction on objects moving through them? Now, Kusuma, can you answer? Can you tell me, what do you think? Will liquids exert friction on objects moving through them? In liquids it is possible. Okay, Sarishma. So what about gases then?
Ma'am, gases means how, ma'am? I didn't understand that one.
Okay, gases means, so you know what is solid, right?
Yes, ma'am.
You know what is liquid. Liquids are something which is flowing. We can't
Yes,
say
ma'am.
flowing. Yeah, like water, oil, all those are liquids. Okay. Now gases are something like the air we breathe. Air is a gas, right? Now, so now yeah, you wanted to know how they are. Okay, what I am asking. So suppose that something is
Yes,
moving in
ma'am.
air. Okay, Sarishma.
Yes, ma'am.
Okay, something is moving in air. So will it face a frictional
Yes, ma'am.
force?
It will possible, ma'am.
Okay. Okay. Now Sarishma is saying that. Okay, Kusuma. Okay. So Kusuma is also saying it is S. Yeah, I got so many S's now. Okay, then let's see. Today we will discuss if there is something, if there is a friction between objects moving through air or water. Okay, now let me give you an example. So in water, how I am asking this question. So suppose you are swimming. So who all knows to swim while traveling? Okay, Sarishma is giving me examples. Okay. Okay, suppose you are swimming. So how many of you know to swim? Is there anyone who knows to swim in the class? Have you ever swimmed in a river or in a pond or somewhere?
Yes, ma'am.
Who is that? Okay, Sarishma.
Yes, ma'am.
Mahidhar, okay. So there are two people who know how to swim. So when you are, suppose you are trying to swim opposite to the for the current, water current. Okay, how do you feel? Is it easy to swim opposite to that water current or?
No, ma'am.
No, ma'am.
It will oppose from that wave.
That wave will oppose. So it is difficult to swim, right?
Yes, ma'am.
So do you think that is some liquid friction?
Yes, ma'am. Yes, ma'am. Ma'am,
Yeah.
another example is while keeping the oxygen cylinders and will go inside the swimming pool and try to push a ball, ma'am. Practice football. It will be also very difficult.
Okay. You have tried that?
No, ma'am, but I saw.
Okay. Okay, she is even giving me more examples. Yeah, Sri Lata. Okay, that is not Sri Lata. That is yeah, Yogesh. Yeah, Yogesh knows to swim. So many knows to swim. Okay, good. So that's a good thing to know how to swim and all. So those who have watched swimming also could understand what I am trying to say. So when you are trying to swim, if you are swimming in the in a river, suppose you are swimming in a river, and if you are swimming in the direction where the river is flowing, in the direction of the river, then it's very easy to swim. Then when you are trying to swim opposite to that direction of the river flowing, opposite to the direction of water, or direction of motion of water. Okay. So that's so there we can see something is opposing our motion, something is not allowing us to swim properly. So that means that we are trying to move. So we know that frictional force is something which opposes the motion of objects, right? So when you are trying to swim forward, so let me draw it and show you. Yeah. So this is your water, suppose, and you are trying to swim in this way. So water is flowing in this way and you are trying to swim. So then it's easy. This motion will be easy. So suppose you are trying to swim in this direction. So motion of water is in this direction and you are trying to swim in this direction. Then what happens? Something is not allowing. So there is, your motion is happening and there is some frictional force in this water which is not allowing you to swim, or which is opposing your swimming motion. So, and we are going to learn what is it. Okay. Now before learning that, The speed will decrease than in one case, in case 1. Yes, Sirishma, that is correct. So, we call gases and liquids in science as fluids. Okay, have you heard of fluids?
Yes, ma'am.
Yes, ma'am.
Okay,
This
so
friction also fluid friction only, ma'am.
I didn't hear that, Pranati.
This friction also fluid friction only, ma'am.
Yeah, it's only fluid friction. I was going to introduce that. So I thought you may not have known this term fluid. So in science we just call liquids and gases together as fluids. Fluids is something which cannot have a proper shape. So you can see even gas, if you take a balloon and blow air into it, the air inside will take the shape of the balloon, right?
Yes, ma'am.
Similarly, if you take water in a cup, the water will take the shape of the cup. So if you take it in a bottle, the water will change its shapes to that of bottle. So there is no particular shape for these fluids. The shape of this fluid, gases and liquids are changing always. So such substances are called fluids. Okay. That's an additional information, you don't need that. So just know that usually we call gases and liquids as fluids. Yeah, Sudhir. Yeah. So fluids exert a force of friction on objects in motion through them, and we give that a particular name. That name is fluid friction or drag. Okay. This is not the drag you were saying in the beginning. So that dragging something is different and drag is different. Okay. This drag is nothing but fluid friction. Okay.
Okay, ma'am.
Okay. So the frictional force exerted by fluids is called drag. So Venkat, can you read this statement?
The frictional force exerted by fluids is also called drag.
There is no also there. Okay, the frictional force exerted by fluids is called drag. Okay, now note this point or underline this point in your textbook. So if someone asks you what is a drag, what define drag or something, you need to know. It is nothing but a frictional force. We give another name for that frictional force of fluids. Okay, that is fluid friction. Yes, correct, Venkat. That is fluid friction. Okay, now can you try to identify the factors which are affecting drag or the fluid friction? So you know the factors affecting friction, right? So tell me, what are the factors affecting friction first? Let me write it down.
Nature of the surface.
Okay, who is that? Okay, Sirishma is saying nature of the surface.
And conditions.
Condition? Okay, Mokshita, what condition? Are you answering this question or this one?
Ma'am, nature of surface is friction's condition only, na ma'am?
Yeah. Okay.
Ma'am, if it is in liquid, how much it is flowing, ma'am?
Okay,
How much force?
Pranati, we will come to this drag, the factors affecting drag. Let's hold that there. Let's first recall what we have learned about the factors affecting friction. So I got only one. There was one more thing, right?
Yes, ma'am. How hard
Yeah.
surface contact are pressed.
Yeah, how hard the objects are pressed, right? So these were the two conditions for friction in solids when we usually consider solids. Now look at the fluid friction. Yeah, Pranati was saying something. Can you continue that, Pranati?
The force means how hard that liquid is force, ma'am. How flow?
Yes, ma'am. The speed of the liquid.
Yes, ma'am.
Okay, Pranati, are you also saying that it was the speed of the liquid?
Yes, ma'am.
Okay, so Pranati, Rajarajeshwari and all were saying the speed of the liquid. Let's see if that is true. Speed of the liquid. Okay, that is one. Now look at nature. We have something like nature of surface here in friction. So do you think this fluid friction will also have something like
Yes,
that?
ma'am.
Yes, ma'am.
Yes, ma'am.
So here there is no surfaces, right? So here there is only the fluid or the object which is moving in or in water or in a air or something like that. So which nature it will be? Show here.
Ma'am, liquids, the speed means the speed of the water will opposes, ma'am.
Okay. So now I am asking, so here in friction we have seen that nature of surface is a condition, is something like friction depends on the nature of surface. So do you think nature of fluid? Okay, Rajeshri is now, yeah, Krishna Kumar is saying irregularities. Okay, that was correct for friction. Irregularities, okay. So as yeah, Sirishma is saying speed of liquid. Yeah, Rajeshri said this drag will depend on nature of fluid also. Okay. Nature of fluid is one condition. So if it is water, if the fluid is water, then the friction may be, the friction may depend on that, whether it is water or it is oil or it is air. Okay. So friction depends on that. Okay. We can't say roughness, Pranati, it might be its density, something like that. So you haven't heard about density, right? So we will learn more about all these in your future classes, like in 9th or 10th. Okay. Now, yeah. So can you tell me why is the shape of an aeroplane similar to birds? So have you noticed this? So here you can see an aeroplane and a bird. They are kind of similar, right?
Ma'am, these two wings are balancing the pressure exerted by the air, ma'am, and they can fly in air.
Okay, now Pranati is saying it is because of pressure exerting by the air, okay, air pressure. Okay, let's look at that. Okay, I'll keep that. Is there any answers, any other answers? Sushmita, what do you think?
Yes, ma'am.
Okay, tell me what could be the reason why their shapes are kind of similar. Okay, I got something. To fly, Krishna Kumar, yes, it is to fly. So think about something relating to our friction maybe. So we just discussed about fluid friction. So now think like that and you will get. Okay, I am not getting any answers. Okay, Sirishma, what do you think? Is the shape of, why is the shape of an aeroplane and that of a bird is kind of similar? It is to fly. I got two answers like fly, air pressure. You haven't thought about this one? Okay, let me tell you.
Yes, ma'am. The aeroplane wings will be balanced the air pressure, ma'am, which is pushing.
Okay, now aeroplane wing, you are considering the wings. Okay, now let me show you. Even a fish. So if I draw a fish, okay, my drawing may not be that good. Okay, I'll try to draw a fish. Consider a fish, a bird, and an aeroplane. So do you think their shapes are kind of similar? So this is my fish, okay. So now do you think? Yes. Okay, they are given, so you know we have just now learned that there is some friction in fluids, that is there is friction in air also. So since air is a fluid, and aeroplane, bird or a fish, they are moving, right? They are not like birds. Okay, let's take the situation of fishes. They are always moving in water. Okay, now this aeroplanes, they they are flying, right? Even birds are flying. So that is a kind of motion. So there should be something which is opposing them, that is our friction might be there. So fluid friction might be there, right?
Yes, ma'am.
So now let me say when, okay, so there is fluid friction, and when these objects like when aeroplane and bird or a fish, when they are moving, so we know that friction produces heat. We have learned that in last class, I think so, last or maybe on Wednesday we have learned that, right? Friction produces heat. So it produces unwanted heat sometimes. So have you heard of plane crashes or something like that? Even when you try to launch a rocket, like when it is just going into the layers of atmosphere, it just explodes, something like that. Have you heard of that? Rocket explosions or aeroplane explosions? Yeah, one of the reasons why that is happening is because our objects, our plane or rocket, it's moving, so it is going against a force, that is our friction. So fluid friction is always there, and when the speed of the object, so we have seen that speed is a factor which our fluid friction depends upon. When these objects, when our aeroplane, so when our aeroplane is trying, it is moving very fast, the fluid friction will be very high. So it is our speed of the aeroplane is very high. Similarly, the frictional fluid friction, that is the drag, is also very high. So since our fluid friction produces heat, there will be a generation of high heat. So temperature will rise suddenly at the tip. So then what happens? It catches fire. Okay, that is one of the reasons why there is an explosion, when sometimes there happens to be explosions in aeroplanes or in rocket launch especially, that happens because of friction. Okay. Now let me tell you why there is why we are giving a special shape to these objects like aeroplanes or rockets. They all have a shape, the tip will be something like this. See, in our aeroplane or in our helicopters, the tip of the aeroplanes will be like this. Even rockets have a tip like this. So if you have a rocket like this, then the tip of the rocket will be something like this, right? So when objects move through fluids, they have to overcome the friction. So in this process they lose energy. So opposing friction, they need some energy. So their fuel is getting reduced because of their fuel is getting reduced in an attempt to overcome this friction. So they lost their energy. Now so then what happens to overcome this fluid friction or the friction? They will be generating some, their fuel will be lost without any reason, without much they are losing their energy. So in order to not to lose their energy, we try to reduce friction, and then we look into nature. So we can see that birds are always flying. They are not knowing about this fluid friction, or even fishes, they don't know about fluid friction, but they are moving quite simply, right? They are moving efficiently in there. So then our scientists, they thought about how they are doing that, and then they came into a conclusion that this kind of shape, so this kind of shapes reduces friction. So that's why our aeroplanes, our rockets or things like that are having a special shape. Now aeroplanes, their shape is similar to a bird because birds are flying always in the nature. So we have always seen that there is no problem with the birds to fly in the atmosphere. So then they have concluded that this shape is something which reduces fluid friction a lot. So that's why we arrived at this shape for an aeroplane. Okay. So did you understand what I was telling? Okay. Did you understand? I am getting some. Okay, Sirishma. So, now, Sirishma, let me ask you. So, did you understand, did you get the point that there is friction in air? Okay, Sirishma?
Yes, ma'am.
Okay, there is friction in air. So, when an aeroplane is moving, so it is having a motion, and there is friction always in the air. So, friction will definitely oppose this motion, right? Are you following, Sirishma?
Yes, ma'am.
Okay, so our aeroplane is moving. Okay, so our aeroplane is moving and friction is opposing its motion, and then what happens? Friction produces heat, that we know, right?
Yes, ma'am.
So, to overcome this heat, our aeroplane has to apply some fuel, or they have to exhaust some fuel of its own, or they has to make some arrangement so that their energy is not lost to withhold this heat that is produced. Okay. So our scientists, they thought about how to reduce this fluid friction, how to make our movement easier. So, as you were saying, when you are swimming against the current, it is very difficult to sink, right?
Yes, ma'am.
So, similarly they thought how to reduce this friction. So, then they looked at our birds as well as our fishes. So, when they looked at them, their shapes are kind of similar, and they are having a shape, and they are moving very efficiently through these fluids, right? We can also see fishes are moving, birds are flying. So, they should also be feeling some kind of friction, fluid friction, but they are moving efficiently. Then our scientists found out that this kind of shape, the shape of a bird or a fish, so this kind of shape reduces friction. So, they shaped our planes and our helicopters or our rockets, so in this shape, a curvy shape, okay, this avial shape. So, are you following this, Sirishma?
Yes, ma'am.
Okay then. So, that's why the shape of an aeroplane is similar to that of a bird. Okay.
Ma'am.
Yeah.
Yes, ma'am. Why that curved shape only, ma'am? We can keep any square shape, no, ma'am.
Now, square shape, what happens? The area is kind of larger, right? So, if the contact is larger, what happens to friction? So, you are moving in this way, friction is in this way. So, if contact is high, what happens? Friction increases, right? Isn't it?
Yes, ma'am.
Yes, ma'am.
Yeah. So, after testing so many times, they come up to this shape. Okay. So, when you grow up and when you become a scientist or something, you can come up with another shape. Okay. Try to come up with something much more like super looking, good looking thing, not like this curved one. Okay.
Okay, ma'am.
Yeah. So, now can I say that fluid friction is depending upon the shape of the object? Now, are you agreeing with that?
Yes, ma'am.
Yes, ma'am.
Yeah. So, another factor affecting fluid friction is shape. So, we have
Shape.
Shape.
three factors. What is that? First one is
Shape of an object.
shape of an object. Okay, next one, speed of the object with respect to the fluid. Now, I am talking like speed of an object with respect to the fluid. So, if something is moving, you know what is with respect to, right? With respect to. So, you are considering the speed with that of the fluid. So, you know that air may be moving. You can feel air moving like in breeze or in storms,
Yes,
right? So, that is why we are telling the speed of the object with respect to our fluid. So, with respect to fluid. And the next one, next point.
Nature of the fluid. Nature of.
Yeah, nature of the fluid. So, whether if it is a water or air or oil, something like that. So, nature of fluid. So, these are the three things. Now, so who will read this for me? Venkat? Where is Venkat? Okay, Krishna Kumar, can you read this statement?
Ma'am, I'll read.
Frictional force depends on the shape of the object and the nature of the fluid.
Okay, thank you, Krishna Kumar. Now, Kusuma, can you read the next one?
Yeah, ma'am. The frictional force on an object in a fluid also depends on its speed with respect to the fluid.
Okay. Now, who will tell me what are the factors that are depending on that frictional force depend upon? Okay, that's Sriraj. Okay. Okay, I would like. Okay, Rajeshwari, can you try?
Yes, ma'am.
Okay.
Frictional force, ma'am. About
Not frictional
Match.
force, but fluid friction. The factors which are affecting fluid friction.
shape of the object,
Mm-hmm.
nature of the fluid,
Nature of the fluid.
speeds of the object, speeds of the liquid.
Not the liquid, speed of the object with respect to fluid. Okay. So, you are considering only the speed of the moving object, not that of the fluid. Okay.
Okay, ma'am.
Okay. Now, note this down in your notebook. The third statement. So, these are the factors that are affecting frictional fluid friction or drag. Okay.
Okay, ma'am.
Okay. Now, so I have a question here. Why do kabaddi players rub their hands with soil? So, have you watched kabaddi? Kabaddi, the game kabaddi?
Yes, ma'am.
So, okay, who is that? Okay, now Sriraj is saying he has watched kabaddi. Okay, no one else have watched this game? It's a very interesting
We
one.
will play also, ma'am.
You will play. Then you know this, right? So, before going into the opposite arena, will you try to rub your hands with soil? Have you
Yes,
tried
ma'am.
this? So, why do you do that?
If opposite players
get
have
this,
sweat
ma'am.
and oil, ma'am, we will catch them.
Okay, now
Ma'am,
I got.
our hands will fill up of sweat, ma'am.
To get grip, we
Then
will
we will
use
rub with sand.
ma'am.
Okay, one at a time. So, I was getting 3 answers right now. I'll repeat whatever I have heard. Okay, the first one was to get a grip from Sirishma. Pranadi was saying our hands are getting slippery because of sweat, so it will something like that. Then I think Rajarajeshwari or Sriraj, someone was saying what was that? If the opposite team has someone with oil or something. So, all your answers are leading to the factor that you so if you rub soil in your hands, you will get some kind of grip. So, your hands won't be that slippery. So, when you try to catch the opponent, so when you try to touch him, it is easy for you to do that, right? So, is that the point? So, now,
Yes, ma'am.
now tell me this with reference to our friction. So, why are you doing that rubbing with soil thing in your hands? Now, tell me with reference to friction. I would like to see your answers in the chat box. Okay. Why do we rub our hands with soil when we are playing? To fill irregularities. Okay, Sriraj is still with irregularities. Okay. Now, irregularities. Now, friction is caused by irregularities. So, can you say it is something about friction, Sriraj? So, what happens when you rub soil in your hands? You get grip, but what happens? Why are you doing that? Now, since we have learned so much about friction, you can tell me. Is it to increase friction or to decrease friction? Tell me that.
Decrease friction, ma'am.
Okay, now Sirishma is saying decrease friction. What about you, Kusuma? What about you, Madhuri?
Same, ma'am.
Yeah, Sriraj increase. Okay. Same. Okay, Kusuma is saying same. So, whom are you agreeing? To whom are you?
Sirishma, ma'am.
Sirishma. Okay. Now, I have another answer. Okay, Madhuri, can you try to answer through chat box? Is it to increase friction or to decrease friction? Mokshida, can you answer? Ramya, sorry, Sushmita.
Yes, ma'am.
Okay, tell me, is it to increase or decrease friction?
To decrease friction, ma'am.
Okay, now tell me, let me give you an example, something like this. So you are trying to hold a glass tumbler. Okay, in kitchen you are going to take a glass to drink some water. Okay, suppose that it has some oil on it. So then will it be easy for you to hold it or will it be difficult for you to hold it?
Difficult to hold it, ma'am.
So you are
Hold,
saying
ma'am.
it is difficult to hold. Okay, and why is it difficult?
Because of
Because
irregularities, ma'am.
with the irregularities on the glass and our hand, ma'am. So it is difficult to handle it.
Okay, I think you said, because two were saying, I couldn't correctly point out. So I think you said, so when the irregularities are getting filled up with the oil. Okay, then tell me, in this case, is friction less or is it greater? So when the glass is covered with oil, okay, in that case, is friction less or is friction high here?
Less, ma'am.
Okay, here, so you are telling friction is less, that's why you are slipping. Now tell me, so I got so many answers in this case. Why we are rubbing our hands with soil? It is to decrease friction. Is it to decrease friction?
Yes, ma'am.
See, if you increase friction, you are getting more grip, right? Look at the glass. If it had more friction, more, if it was not so much slippery, then what happens? You will be able to hold it. You will be able to grip it. So since there are so many irregularities, friction will be higher. So that's why you are applying soil to your hand. Okay. So when you apply soil to your hand, you are getting the grip because friction is increased. So you are doing that to increase friction so that you will get a grip. Your hands, like with sweat and all, if your hands are sweaty, what happens? It's just like our glass having some oil. So it's very difficult for you to grip the other person or to touch the other person, grip or hold the other person. So we apply some soil so that friction is increased, so that you get the grip. Okay. So the answer is correct for Sriraj. Congrats, Sriraj. Others, please. Yeah. Okay.
In the chat box, I cut the message, ma'am.
Okay, I see that now. Yeah, friction, right? More friction. Yeah. So others, please think about it, and if you are not still getting the point, contact me after the class. Okay.
Okay, ma'am.
So many have told me it is to decrease friction. Okay. Now tell me, why is the sole of your shoes grooved? So I will show you that pic. So usually especially running shoes, they have something like, they are not soft, there will be something like engraved in within.
Spikes.
Yeah, spikes, especially, yeah, spikes in case of those athletes who are running. So when you are running, you usually use spikes, right? Similarly, so in this case I am asking about your normal shoes or your chappals. Why is it not flat? So it is not flat like this, but it will be having something like this. Your chappal also is having that.
If it is flat, we will slip, ma'am.
Okay, if it is flat, we will slip. So why are we keeping, so tell me with reference to our friction.
If there are no irregularities in the chappal, there will be less friction, ma'am. It leads us to slip.
Yeah, so we do all this grooving in the chappals because to increase friction.
Cost of friction, ma'am.
Okay, cost of friction. Okay, I didn't get that. Okay, so we do that so that we get more grip, and we do that to increase friction, right? In both these cases, we are doing this to increase friction. That means we already know friction is a necessary evil. So it can be a good one, it can be a bad one. So here in these cases, we are trying to increase friction. Okay. and we are able to do that. So, by using some kind of, say in this case we used soil so that we are increasing friction. In this case we are using grooves, even tires are treaded. So, see the pattern of tires especially in bigger vehicles like buses or big lorries. So, when they load so many of things, so much heavy things, their tires will be usually very highly treaded like this. So, they will be so that they will get that grip. If they slip, they won't be able to apply brakes if the tires are smooth. Okay, brakes won't work there. So, that's why we are doing this. So, this means that we can increase friction. Okay.
Okay, ma'am.
Now, have you played this?
Yes, ma'am.
Yes, ma'am.
Yeah, this is carroms. So, have you ever put some fine powder, something powdery on top of this so that it will go smoother? Have you tried that?
Yes,
Yes,
ma'am.
ma'am.
Now, why do we sprinkle fine powder on the carrom board? Tell me why we are
To
doing it.
move smoothly, ma'am.
Ma'am.
To reduce the friction.
Yeah, yes, now you are getting the point, to reduce friction. So, that means we can reduce friction by using something, right? So, let us go to this situation. Here, yeah, we saw this one in the first class, right? So, this man was slipping and falling. So, we understood that between the floor and the shoes of the man, the banana peel is filling up the irregularities. So, in the case of our carrom board, so let us think this is our carrom board instead of floor.
The powder will fill irregularities.
Yeah, our powder is filling up irregularities. So, this is our powder and this will be our striker. Okay. So, then what happens? So, the things that we use to fill up or to reduce friction, such things are called as lubricants. I got this answer in yesterday's class also. So, someone was saying lubricants. So, the substances which we use to reduce friction is known as lubricants.
Lubricants.
Okay. Now, have you seen this indoors? So, these things are called hinges. Okay. Have you seen this?
Yes, ma'am.
Yeah.
Yes,
Now,
ma'am.
if your drawer is making some noise, like creaky noise, something creaky when you try to open and when you try to close it, if it is making some noise, you will pour some kind of oil, any oil on these hinges, right? Have you done that? Have you ever done that?
Yes, ma'am.
Yeah. So, why are we doing that?
To reduce friction.
Reduce friction.
Yeah, to reduce friction. So, when we apply oil or grease or graphite between anything that is moving, so like a hinge, so hinge is actually moving, right? So, a thin layer of this coats the surface and then the irregularities are filled with this coating, and then the surfaces are not in direct contact with each other. So, then that will decrease friction, as you are saying. So, the movement becomes smooth, and this is the point you need to note. The substances which reduce friction are called lubricants. Yeah. So, can you tell me some examples for lubricants?
Grease, oil.
Grease.
Tree, I didn't get that one. Soil, okay.
Grease, sir. Grease, ma'am.
Oh, grease, oil, yeah.
Ma'am, then soil also a lubricant, ma'am.
Yeah, soil becomes a lubricant when you are applying it in that way, okay. So, when you are,
Okay, ma'am.
that should be fine.
Ma'am, then powder.
Yeah, powder is there. So, and soil should be powdery. No. So, you are applying it to, soil won't become a lubricant. So, can you tell me any occasion where you are using soil to reduce
In kabaddi, ma'am.
Okay.
In
To
kabaddi.
increase friction,
In
not
kabaddi
to
we are
reduce
increasing. Yeah, we are increasing friction, right? Soil is not smooth. So, usually the lubricants are smooth things. They are smooth, and like the fine powder or oil, they are very smooth.
Ma'am, is ghee a lubricant?
Yeah, ghee can be lubricant. Yeah, but we are not using it as a lubricant officially because it is costly. Yeah, someone must say something. Okay, ghee can be in the category of a lubricant. It's a lubricant. Now, in some machines you cannot apply oil. So instead of that, there will be an air cushion. So air is also a lubricant in that case. Okay. So air can also be a lubricant. Now, this is the question we discussed in the last class. Now tell me why why our luggage bags are fitted with rollers. Slippery. Okay, tell me
To
first.
reduce friction.
Yeah, to reduce friction. So we just learned that friction can be increased as well as decreased. So according to our need, we are going to increase or we are going to decrease, right? So friction is very necessary for us, as well as sometimes it's very harmful for us. Okay. Now, the frictional force exerted by fluids is called drag, and it depends on three things. It was the shape of the object, nature of the fluid, and speed of the object with respect to that of the fluid. And now another thing is fluid friction. Okay, this is not necessary. Okay, yeah. So we saw that friction can be increased as well as decreased according to our need. So can you give one example where you are increasing friction?
Kabaddi match.
In game of kabaddi, ma'am.
Yeah, so you are increasing, if you are going to give the game of kabaddi, then you need to elaborate a bit more, or you can just say the sole of shoe is grooved, the tires of a vehicle is grooved, right, threaded. So if you are giving kabaddi example, explain it a little bit. Then we have seen what are lubricants. The substances which reduce friction are called as lubricants, and we have seen so many examples for lubricants also. And so friction can be reduced by lubricants. Now quickly answer the first question. Sprinkling of powder on the carrom board dash friction.
Reduce
friction.
So is everyone agreeing with that? We are reducing
Yes.
friction.
Yes, ma'am.
Okay, the next question. Explain why sportsmen use shoes with spikes. Yeah.
To decrease friction.
Okay, I got it. Decreasing friction. Is that decreasing friction?
to increase.
To increase, ma'am.
Okay, this one you take it as a homework and think about it and tell me in the next class. Okay, that will be Monday.
Okay, ma'am.
So this one I got two answers, increasing, decreasing, right? So this just feels a little bit tricky. So you people go and think. I am not going to answer this one. Okay, the next one is explain why objects moving in fluids must have special shapes. Look at our aeroplanes. Why are they?
Reduce friction.
To reduce which friction?
Fluid friction, ma'am.
Drag, ma'am.
Yeah, fluid friction or drag. So to reduce fluid friction or drag, we are using a special shape. Okay, now, so think about this one. Can we reduce friction to 0? So we have just seen that lubricants can be used on surfaces and we can reduce friction. So do you think we can reduce the friction to 0? Normal? Oh, no, okay.
No, ma'am.
Okay, think about this. I'll keep this in group also. So what is,
Okay, ma'am.
okay, this question I'll keep it in the group. Okay, is